Question 3 says an astronaut rotates around the end of a test machine whose arm has a length of 10 meters, as shown. If the acceleration she experiences must not exceed 5 Gs, what is the maximum number of revolutions per minute of the arm? So let's set this up. Her acceleration is going to be 5 Gs, which is going to be 50 meters per second squared. The radius of the arm is going to be 10 meters. And what is the maximum number of revolutions of the arm? So with this, we're going to find max RPMs. Okay, so working through this, I'm going to say, first off, acceleration equals v squared over r. So the thought process I'm going to go through is I'm going to first find velocity. And then what I'm going to do is I'm going to determine the number of revolutions per minute based off of the velocity. Okay. So the velocity then is going to equal acceleration centripetal times the radius square root. So the velocity that she would be traveling would be 50 times 10 square root, or the square root of 500. That's going to give me a velocity of about 22.4 meters per second. Right? And so if we think about then, how do we determine revolutions per minute? Well, the one revolution is going to be 2 pi r, the circumference, or the distance that she would travel. So it's going to be 2 times pi times 10, which is going to be 62.8 meters. And she is traveling at 22.4 meters per second. So then what I'm going to do is I'm just going to find the number of revolutions per second. And I'm going to do that by saying, well, if she does 22.4 meters per second divided by 62.8 meters, that's going to give me 0.35 0.36 revolutions per second. Because one revolution is 62.8, she does 22.4 meters per second. So she goes about a third, just over a third revolutions per second. And then what I can do is simply multiply that by 60 seconds, because we know that there's 60 seconds per minute. And that's going to give me 21.4 revolutions per minute. Or we'll just do RPMs. Or really this would be revolutions minutes to the negative 1. That's how IB would write it. But yeah, just 21.4 RPMs.